Hey, Everyday Stats, welcome to your lesson 1.3. We're going to be analyzing one variable data as we have been all throughout this chapter 1. Today, we're going to do that by looking at dot plots. So what we're going to do today is we are going to make and interpret some dot plots. We're going to be able to describe the shape of a distribution from looking at a dot plot, and then we'll compare two different dot plots and look at those two distributions. So here is an example of what a dot plot is right there. Let's talk about how we read this dot plot. So this entry right here, we have 0 siblings, right? And these 4 dots right here are telling me that of all these people we asked, hey, how many siblings do you have? There were 4 people that said, I am an only child, or I have no siblings, 0 siblings. All right, so that's how we'll read a dot plot. We're going to go ahead and make one at the end of the lesson together. Just really important, make sure that you draw and label the axis, and the label is so important, right? If you haven't labeled your axis, then it's not right. So make sure you do the label. We're going to scale the axis. We're going to plot the values again. We'll go through this all together here at the end of the lesson. So I won't read this to you. We'll just get to it. All right, so when we're using a dot plot to display some data, we're able to look at the shape of the dot plot and describe it as either symmetric, skewed right, or skewed left. All right, so we're looking for peaks, like the tallest point on it, and we're kind of looking at what happens at the end. All right, so let's look at this. Our roughly symmetric distribution that we've got here. Notice that it's pretty even on both sides, right? You can see that it's got like a middle point right here. And then you'll also notice that, you know, this side's not exactly the same as this side, but that's okay, right? You're seeing a roughly symmetric or like a mound shape, right? So if you see that nice mound shape with the tip in the middle, we might say that that's roughly symmetric. How about this one? When we got something skewed to the left, and it seems counterintuitive, right? Because it says it's skewed to the left, but it looks like most of the data is over here on the right-hand side of it. So the way that I like to do that, I like to imagine that this thing has a nice smooth shape, and then it's got a little tail out here. So what I do when I'm determining if a distribution is skewed to the left or right, I try to look at what side the tail is on, right? So if the tail is on the left, it's skewed left. In this case, if I draw this smooth line over it, right, we've got our tail here on the right. And this is right skewed data that is skewed to the right. So if we're given a graph, there's some things that we could look for. And some of these things we can get from this graph, and some of these things we can't. So when you're being asked to describe a distribution, we're going to describe its shape, center, and variability. In addition, we're also going to look to see if there are any extreme values or a value that doesn't really kind of fit with the pattern. So if we look at this particular distribution of data, if I was to draw a smooth curve, right, my tail would probably be out here, right, on the right hand side. So we would say that the shape of this data, right? So when we're talking about symmetric, right skewed or left skewed data, we're describing the shape of the distribution. In this case, the shape appears to be right skewed, or you could say skewed right as well. The center, we'll learn later on in the chapter that measures of center that we're going to use are going to be mean and median. I could find the mean and the median from what I've got uh, here, um, but I'd have to do some calculations. I couldn't get it straight from the graph. So we'll talk about measure of center later. Variability is talking about kind of how spread out the data is. This particular distribution doesn't look very spread out, but look at this guy right here. This is an extreme value. Doesn't fit with the pattern. May even be what we're going to call an outlier, and we'll define that later on. But for now, we're just going to recognize this as being a data point that doesn't fit with the overall pattern. All right, so if we're going to compare two dot plots, we need to compare shape, center, and spread. And with the center, right, we're not going to give an exact calculation. We'll just talk about where we think the middle of the data is. So when we talk about the shape, it looks like the distribution for South Africa. I'm going to just put SA here. Try to save us a little time. Stats for South Africa appears to be skewed right. While the distribution for UK what does it look? It looks roughly symmetric. I wouldn't say that that one is skewed left. I would want there to be, I would want to be pushed over a little more to the right and have more low values over on the left-hand side of the graph. So this is roughly symmetric. Okay. If we were to look at the centers of these, we're not going to get too crazy about it, but maybe the center of this is somewhere around here. I'm making a full estimation, right? Well, the center of this data seems to be a little bit less. So I would say that the center of the data for South Africa seems to be greater than the center of the data for the United Kingdom. And how about variability or spread? I call it spread sometimes. The book right now calling it variability. We're talking about how spread out the data is, though, when we're talking about variability. So it looks like the data from South Africa is more spread out than the data for the UK. And there we go. We have described shape, center, variability, and we compared each one between the two different distributions. All right, so let's go ahead and do one together, and then we'll make a dot plot as well. All right, so let's do an example of comparing two distributions that we're given a box, or sorry, a dot plot for. So we've got, you guys can read the lead up to this, right? We're looking at concentrations of nitrites, okay? So in milligrams per liter, it looks like. We took 42 places from Stony Brook, and looks like another 42 from Millbrook. Let's go ahead and answer some questions, and then we'll also be able to compare these two. So what does the dot above the 12 in the Stony Brook graph represent? Well, let's find that thing. Stony Brook, the dot, oh, can't see it, above the 12. So we're looking at this 12, right? We're going to go back up. So we're talking about that dot right there. What does that mean? That means that there was one place on Stony Brook where they found the nitrate concentration was 12 milligrams per liter. What percent of the nitrate concentration measurements for each stream exceeded 10 milligrams? So for each one of these streams, if we're looking at which one exceeded 10 milligrams, how many exceeded? So essentially we got a cutoff going right here, right? So how many of them were there? There were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of those guys. 13 out of, how many were there? Well, if they took 42 from each stream, we got a total of 84. We'll go ahead and calculate that by dividing 13 by 84, right? 13 divided by 84 in my calculator is going to give me approximately 0.155, right? Or let's go ahead and round that and say that's about 15.5%. Or I had rounded it previously, and now we're going to express it as a percentage. All right, fantastic. If we look at the centers of these two distributions, right, about where the middle might be, I might imagine that the center of Stony Brook is somewhere over here. Well, the center of Millbrook is probably around here. So it looks like the center of the Stony Brook distribution is lower than the center of the Millbrook distribution. Answering number 2. For number 3, I'm sorry, we compared the number 4. I forgot all about number 2, I guess. All right, so is the variability in nitrate concentrates for the two streams similar or different? What would you say? How spread out is the data? How much does the data vary? Well, it looks like Stony Brook, right? Our range is only from here to here, right? Well, we've got a huge range for Millbrook. So I would say that the distribution for Millbrook is has much more variability or variation in it than Stony Brook. Fantastic. Well, let's go ahead. And remember, I promised you that we would make a dot plot together. Let's go ahead and get that done. So this is actually number 1 in your exercises in your book. And we're looking at some data on lengths of the first 25 words in a randomly selected page from Harry Potter. And I don't know why you would do that, but hey, we've got some data. So number 1, we're going to go ahead and draw our axis. Maybe I'll draw a straighter line. Maybe I won't. Who knows? I think that's better. Okay, now that we've drawn that, what is our label? Let's make sure to label it right away. What is this? This is number of pages that we're going to be graphing. All right, and we're noticing when we look at the data here, we are noticing that what's our highest value? I'm seeing an 11 here. Is that it? And our lowest value is, it looks like 2. So we're going to take this thing from 0 all the way up to 11. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hey, I'll put in a 12, even though we're not going to go all the way up there, right? So there's 11. So we'll label these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'll put in the 12 just because even though we don't have a value for 12. And now I'm going to go through the data and I'm going to start making a dot for each one. So my lowest one, it turned out, was 2. So I'm going to go through and I'm going to mark each of the 2s. So there's 1, 2, and I will put my dot there, okay? There's another 2, let's put a dot for that 2. Here's another 2, we'll put a dot for that 2. Another one, a dot for that one. We'll just keep going through this until we get it. All right, let's look at 3s. There's a 3 and a dot. 3 and a dot. A 3 and a dot and a 3 and a dot. I'm trying to make it cooler. There's a 4. You got another 4. Another 4. Another 4. Ooh, my dots are getting sloppy. Another 4. Sorry, that's really not looking good. Let me fix that. See, it's nice for them to line up, right? So that you can actually compare them. So then we were just missing this last 4. Let me make sure there are 1, 2, 3, 4, 5, 6 4s. 1, 2, 3, 4, 5. We need one more. All right. 5, there is 1 5 there. Oh, there are 2. And a 6. There is a 6 there. I'm not crossing these guys out as I go. 7s, there are 2 7s. 1, 2. Oh, there's a 10. And then there is an 11. And there we go. We did it. I mean, just for kicks. Let's notice that it appears that this distribution is skewed to the right because the tail is off over to the right-hand side. It's just kind of something that I'm noticing right off the bat. But there it is. We drew, we have constructed our dot plot. All right. So that's it for the lesson today. Today we did all of these things, and we're so happy about it. So thanks for watching Everyday Statistics. I hope that you're having a fantastic day, and if you're not, I hope it gets better. Thanks.